So before we begin the third graph, which is the velocity time graph, I would like you to pause the solution here and try to explain it to yourself. The analysis of this graph, velocity time graph, exactly the same way we did for the velocity displacement graph. And then try to understand and try to question yourself what kind of data is given to us, what kind of graph is given to us, the y-axis, the x-axis, the mathematical feasibility of this equation, the physical aspect of the equation. Is it actually possible? Is there any graph that is similar to the one given in the ncrt? And what question can we expect in the future based on this? Things like that. Try to ask these questions to yourself. Okay, so pause it. So what does this graph represent? We have a circular graph here, right? Now, this graph, my bad, give me a second. Yeah. So this graph is actually a circle with which has a specific radius, and the equation being t square plus b square is r square. That is x square plus y square is equal to r square, which is the exact equation of a circle. And if we rewrite that equation as v square plus t square is equal to r square as v square is equal to r square minus t square, and if we solve for v, we get two values. One, which is plus root of r square minus t square, and two, which is minus the root of r square minus t square. So if we have two roots for v, what would this imply? So in a circular curve, if we have two values for v, it implies that there are two, exactly, there are two possible values of v, which is there are two possible values of velocity, right? Now, oh, my bad. This is not meaning of two negative values. It should be meaning of two values instead. I stand corrected here. Please, while if you're taking it down, please make sure you don't write this one down. It's only meaning of two values. Okay, so the meaning of two values is that we have two individual values of velocity. From the point of view of a of a mathematical analysis here, for each input t, we get two corresponding velocities of v. For each input of time, we get two velocities of two corresponding velocities, which means this graph is practically not possible. Why is it practically not possible? Because because at one instant of time, it is physically impossible to get two values of velocity, one being positive and the other being negative. So if I were to draw a line here like this, it means that at this point of time, at this instant of time, we have the one object having a positive velocity and the same object having negative velocity as well. So that's not practically possible, right? Okay. Now, again, we are talking about the mathematical aspect here. So velocity is a function of time, right? Which means at each instant time, velocity must have only one value. But the given equation here shows that v has both positive and negative value, which makes it not possible, right? Now, some of us might have a question here. Is this graph incorrect? Because it shows time in the negative axis here. So this is time t is equal to 0 and time t is equal to positive. Is it negative? Because we've been given that time is negative, which time can't be practically and physically. This graph is wrong, therefore. It might seem to be correct for the first time, but then if you dive further into the concept of time t is equal to 0, let's see that. We can observe the time goes negative on the left side here, like on the left axis of time here. That's not possible. That's what we're trying to think. And therefore, this graph should be incorrect. But negative time automatically doesn't mean that the graph is wrong. Why? Because we know exactly, we were just discussing the case of the swing there, right? So we know that time t is equal to 0 is not the actual start of the motion. It is rather the start of observation, which means time t is equal to negative 2 actually implies the instant of time which is 2 seconds before the actual observation started. It doesn't mean negative time in its essence. Okay. So plotting this t is equal to negative value doesn't mean that a graph is mathematically inconsistent. It just means that we are talking about those actual instances of motion which was happening before the actual observation took place. I hope that makes sense. Okay. Now, if you observe t is equal to minus 2, it just means this is something that happened 2 seconds before we actually started measuring the motion. It's like rewinding a video. It is still real, but it happened some time before. Okay. Now, there is something in addition to what we have discussed so far. If we differentiate this equation, t square plus v square is equal to r square, what we get is d by dt of, okay, let's make it quick here. 2t plus 2v is equal to 0. Vv dash is equal to 0. T plus Vv dash is equal to 0. And therefore, v dash is minus t by v. What is v dash? Is acceleration. So acceleration here is minus t by v. This expression makes us think about two different things. One, which is t is equal to 0, acceleration is 0 by v, which is equal to 0. And at v is equal to 0, the acceleration is minus t by 0, which is infinity. In other words, when the graph meets the x-axis, t is equal to 0, or the y-axis, t is equal to 0, and acceleration is 0, uh, uh, I'm not trying to say here this both of them are correct or incorrect. I'm just trying to tell you that mathematically, this, if you extract the mathematical sense of the equation, it means this. When the graph touches the x-axis, the time, where y-axis is 0, which is v is equal to 0, acceleration is minus t by 0, which is infinity. Now, when we have such two observations, we should probably think more deep into that. What am I trying to say? At t is equal to 0, acceleration is 0 by v is equal to 0. So these are the 2 points, time t is equal to 0. These are the 2 points where the graph actually meets uh, the y-axis. So the x-axis is 0, x-axis is time. Therefore, time is equal to 0 is in these 2 points. Correspondingly, we have at v is equal to 0. What happens? The graph meets the x-axis. And the graph here, the circular graph here, is meeting the x-axis in two different points, 1 and 2. And in both points, velocity is equal to 0. Okay. Now let's try to understand what these two observations mean. At t is equal to 0, from differentiation, acceleration is minus t by v. So acceleration is minus 0 by v, which is 0. Now acceleration is 0 implies velocity is 0. Does it? Zero actually. Why? Because velocity at positive r and velocity is actually a value at positive r and minus positive r. So this actually is physically possible. There is no problem with this observation here. To go to go a bit further, if you observe this graph here, the circular graph here, velocity and time here, at this point, the distance is kept plus or plus r, and at this point down here, it is minus r, where r represents the radius. At radius, time is equal to 0 plus r. Time is equal to 0 here as well, minus r. Okay. And in both these points, what we see is if we draw a tangent at t is equal to 0 in both these cases, what we get is a perfect horizontal line which is parallel to the time, to the x-axis. And when a line is parallel to the x-axis, what is the slope? The slope of that line is 0. What does slope represent in a velocity time graph? It represents the gradient. What is gradient of velocity and time? It is dv by dt. And what is dv by dt is equal to? Dv by dt is equal to rate of change of velocity, which is acceleration. So when slope is equal to 0, acceleration is therefore is equal to 0, which is perfectly possible. Yes, nothing wrong with that. Okay. So there is no problem with acceleration at time t is equal to 0 being equal to 0. Then what is the actual issue here? The actual problem here is that at that time t is equal to 0, right? The graph gives two values, which is positive r and negative r. And for one body to have two velocities at the same instant of time is practically not possible. Now, if we were to dive into the mathematical part of this, in real one-dimensional motion, velocity must be a single valued function of time, single valued function. It should be continuous. And if the function is not continuous, exactly something that we have discussed in the basic tools, right? So a particle cannot have two velocities at the same time. Now, the other side of the other thing that we need to think about is at v is equal to 0, which is when the graph meets the x-axis, differentiation a is equal to dv by dt, a is equal to minus t by v, and therefore when v is equal to 0, this is a is equal to minus t by 0, and anything by 0 is infinity, right? Or undefined. Now, when we have undefined, it actually means that if you draw a tangent there, the slope of that tangent is infinity. Slope of a tangent is infinity, which means slope of the velocity time graph is infinity. What is slope? It is gradient. What is gradient? Gradient of the velocity time graph is acceleration, which means that at these 2 points, the velocity of the rate of change of velocity of the object was infinity, which means acceleration is infinity, which is not practical in any real physical system. Okay. So that's another reason for rejecting this graph. So just a quick summary. T square plus v square is r square is the equation of the circle that is given to us, which gives us two possible values of velocity. And two possible velocities at the same instant of time makes it impossible. Negative time is allowed doesn't mean time in negative in its absolute sense, but it means that when we say t is equal to 0, the actual observation was started at t is equal to 0. There is actual motion that is happening even before t is equal to 0, right? And along with this, we have two different problems. One, that if it is a is equal to 0, if a is equal to dv by dt from the graph, we get 2 points where the slope is 0 and the slope is infinity. Slope is 0 is valid, but slope is infinity is not valid. So you can't make two analysis, two observations, one which is physically possible and the other which is physically impossible from the same graph at the same time. Hope that makes sense. There might be a little bit of lack of understanding here. Don't worry, when we go through the written part of this, it will make more sense. Okay.